So for the first lesson of chapter 6, your properties of exponents, I have put a table here instead of just telling you the rules, and hopefully it kind of helps you. So what we're going to have is if we have a zero exponent rule, okay, that means anything to the zero power. So let's say a is my base. Anything to the zero power is 1. Okay, so that means if I have 4 to the 0 power, that's 1. If I took a negative 4 to the 0 power, that's also 1. If I have a variable, say I have x to the 0 power, that's also 1. Okay, so anything to the 0 power is 1. Okay, your product of powers is telling you that if you have any base raised to any exponent times its same base raised to another exponent. So if I'm multiplying bases, my product of powers tells me I'm going to keep that base and I'm going to add those exponents, m plus n. Okay, so what does that look like? Well, if I have x cubed times x to the 4th, I would keep my x and I would add 3 plus 4 to give me x to the 7th. Okay, you have to be careful because everyone's instinct is to see I'm multiplying like bases. I need to multiply my exponents, but that's not the case. You add your exponents. Okay, now if you had something like 2 squared times 2 to the 5th, okay, that would be 2 to the what power? 7. Now, the difference between having a variable and an actual number as your base, you have to evaluate the number. You can't leave 2 to the 7th power, okay? So in your calculator, you're going to have to evaluate it, okay? So you'll type your 2 and then that caret button next to the 7 gets you an exponent, so 2 to the 7th power. So that would be 128. Okay, so anytime you have a number as your base, you have to evaluate. Okay, now my quotient of powers tells me if I'm dividing my bases, so if I have a to the m divided by a to the n, so like bases, they're set up as a fraction, so that means I'm dividing. Okay, I'm going to, if I multiply like bases, I add the exponents. What do you think I'm going to do with these exponents if I'm dividing? Subtracting. So I've got a to the m minus n power. Okay, so if I have x to the 5th power divided by x cubed, I would subtract 5 minus 3 and that would give me x what? Squared. So if I had 2 to the 10th power divided by 2 to the 4th power, what would that leave me with? 2 to what power? The 6th. 10 minus 4 would give me 6. So 2 to the 6th power is 64. Okay, those are your most basic ones. Do y'all understand those three? Okay, so the negative exponent is telling you that if you have any base raised to a negative exponent, okay, the negative exponent tells you essentially it's in the wrong position. Okay, so your rule tells you if you have a to the negative n, that's equivalent to the reciprocal, so 1 over a now to the positive n. Okay, so if you have a negative exponent, you're going to move it down to the denominator. Okay, if you have a negative exponent in the denominator, it means it's in the wrong position. You would move it up to the numerator. This rule is really where mistakes happen. Okay, so you've got to be careful with this one. Okay, so an example would be if I have x to the negative 7th power. Okay, negative exponent means wrong position. I'm going to now flip it and make it 1 over x. Now it's going to be a positive 7. I have now moved it to the right position. So when I mean position, I'm talking about numerator versus denominator. Okay. Now, if you have 1 over x to the negative 4, This is what I meant by, what if it's negative in the denominator? Well, if you associate a negative exponent with the wrong position, all you have to do is bring it up and it just becomes x to the positive 4. And there's no longer a fraction there. Okay? Do we understand that concept? Understanding that it's in the wrong position, you have to flip it, is not what gets people. It's when there's other terms with it, that's the mistake that happens. So we'll look at those in a minute. Okay? Your power of powers tells you if you have any base raised to any exponent, and that's in parentheses raised to an additional exponent, so I have a power to a power, that's what I call it, okay? That tells me I am going to multiply those two exponents, okay? So if I have x to the 4th raised to the 3rd power, I have a power to a power, so I multiply. That's going to turn into x to the what? 12th power. You're going to multiply 4 times 3. Okay? If I have 5 squared, that's really 5 to what power? To the 4th power. And 5 to the 4th power, evaluate that in your calculator, and what does that give you? Okay, do you understand those rules so far? Are we good? Okay. So power of a product and power of a quotient are pretty much the same thing. One's multiplying, one's dividing. Okay. This is telling me that if I have two things in parentheses, two things being multiplied, and all of that is raised to an outer exponent, what that means is each term in parentheses is going to take on that exponent. So that's going to tell me I have a to the m power times b to the m power. You could have two terms, you can have 30 terms. That outer exponent will be basically distributed to each term, okay? So that means if I had something like 2x raised to the 3rd power, okay? I take that outside 3 and I distribute it to each term. So the 2 takes on the exponent of 3, and the x takes on the exponent of 3. Now, if I have a number as my base, what do I have to do with it? I've got to evaluate it. So 2 to the 3rd power is what? 8. So this would be 8x cubed. Okay? Sometimes the terms inside parentheses, which is actually most of the time, it might have its own exponent. Okay, so you might be using power of a product with power of power, and that's okay. All right. Power of a quotient is telling you pretty much the same thing. You're just now taking two bases and dividing them, and that's raised to an exponent. So you're still distributing that outer exponent to make it a to the m power over b to the m power. So whether you're multiplying or dividing, if you have multiple terms inside parentheses with an outside exponent, you're going to distribute that. Okay? So if I have, say, 3 halves to the 5th power, the 3 will take on the exponent of 5, and the 2 will take on the exponent of 5, telling me 3 to the 5th power over 2 to the 5th power. Okay? And then 3 to the 5th power, you should get 243 if you type that in your calculator. And 2 to the 5th power should be 32. Okay? Now, I want to make a note that when you have variables, there's nothing to evaluate. You leave your variable as your base. Okay? With something simple like this, you don't have to show me the x 5 minus 3. Okay? You can go straight to your answer. When you have numbers as your base, I want to see that middle step before you evaluate it. Okay? You have to show me 2 to the 6th before you tell me 64, you're going to lose points. Okay? Because I absolutely understand I could take my calculator and say I had this example, I could type in my fraction raised to the fifth power, and get my answer. But that's not what I'm not testing you, can you type it in a calculator? I'm testing you and quizzing you over your properties. Okay, so that's why I have to see this middle part when you have numbers. Okay, do we all understand these rules? And my expectation of what you see. Okay. So we're going to have a bunch of examples, and with properties of exponents, the more practice, the better for you. Okay, because every single problem can be different. Okay, so our first example, we're looking at, we have 2/5 in parentheses raised to the third power. Okay, so what would I do with 2/5 raised to the third power?
Apply the third power.
I distribute that outer exponent, okay? So that tells me the 2 takes on the exponent of 3, and the 5 takes on the exponent of 3. And then I evaluate it. 2 to the third power is what?
8.
Bless you. Good. 5 to the third power is 125. Now, it's a good habit to check to see if it could simplify. It doesn't take long. You literally just put your fraction, 8 over 125. If it stays the same, you can't simplify it. Okay, so this would be my answer. Okay. Now the second example is if we take 2 to the negative 3 power in parentheses, and we raise that to the second power. Okay, I have a number raised to an exponent, and all of that is raised to an exponent. So that's my power and power. I'm going to multiply my exponent. So that's going to be 2 to what power? Negative 6. Now, when I multiply that, I get a negative exponent. What happens with a negative exponent? You change it. So this becomes what?
1 over 2 to the 6.
1 over 2 to the 6. And then I can evaluate. When I evaluate that, I'm just evaluating 2 over 6. So I have 1 over 2 to the 6th power is 64. So that was kind of 2 rules mixed into one. Are y'all good with that? Okay. So this next one, I have negative 3 in parentheses. And then right next to it, I have another negative 3 raised to the second power. Okay. What is happening between these two negative 3's? They're being multiplied. You have to recognize that's multiplication. Okay. If I know I'm multiplying my bases, what do I do with my exponents? I add them. Okay. Now I don't have an exponent written here, so what would I have? A 1. It's understood to be 1. Okay, so now, even though it looks a little bit different, now do you see what to be adding? Okay, so I should have my base of negative 3, and because it's negative, it stays in parentheses. You have to be extremely careful with negative bases, okay? They have to stay in parentheses or you're going to get the wrong value, okay? So what will be my exponent for this? 3, because you added 1 and 2. So when I type it in my calculator, I need to have that negative 3. I'm trying to get it where you can see it. I have to have that negative 3 in parentheses just like I wrote it. And then that's going to be raised to the third power. So negative 27 would be my answer. Okay. Now this next one, I have 3 halves in parentheses raised to the negative 2 power. Okay. I notice I have a negative exponent, but I have a fraction raised to a negative exponent. So what I do is I distribute that outer exponent and then I do my rearranging. Sometimes it's easier to rearrange it first, but personally, it would not be easier to do 1/3 to the second power and try to figure out that from it. Okay? So if I have anything raised to an outer exponent, you can distribute that first and then do your switching. Okay? So this is going to tell me I have 3 to the negative 2 power over 2 to the negative 2 power. Okay, when you go to switch, you look at each term individually, each base individually. This base has a negative exponent, so that needs to go where? At the bottom. This base also has a negative exponent. It's at the bottom, so where does it need to go? At the top. Do we understand that? Okay. So this becomes 2 squared over 3 squared. So my final answer should be what? 4 over 9. Very good. Okay, now my next example is 2 to the third power over 3 to the negative 4 power. 2 to the third power over 3 to the negative 4 power. Okay. I want you to do that one. Okay, what do you do first?
Bring up the negative.
So this negative exponent tells me it's in the wrong spot. I should bring it up. Now, do I need to bring 2 to the third power down? No. Why? It's already positive. So I'm going to make a note here, and this is where people make mistakes. Okay? So you will only change the term that has a negative exponent. Okay, you only change the term that has a negative exponent. A lot of people want to flip the entire fraction just because they see one negative exponent. You're only looking at the base with the negative, okay? So what that does is tell me I have 2 to the third power now times 3 to the positive fourth power. Okay, another mistake is that when you move it, you leave it negative. Okay, so when you move it, you're putting it now to what we consider the correct position. It's going to be positive. Okay, so 2 to the third power is what? 8. 3 to the fourth power is what? Should be 81. Okay, so what's 8 times 81? So that would be my final answer. Okay, there's no steps to skip. So when you're doing your worksheet, you should be looking at your work and making sure it makes sense with the work that I do. There shouldn't be any less here. Okay? Are we good with the first 5 examples? All right. So example 6, we've got y to the fourth power raised to the fifth power. I want you to do it. What's your answer?
That's what.
Y to the 20. You have a power to a power, so you multiply exponents, y to the 20. Okay. Now, example 7, I have a set of parentheses, and I've got 2y cubed inside parentheses, and all of that is raised to an outside 2. Okay, so 2y cubed raised to the second power. What am I going to have to do with that? I have two terms, okay? The 2 is separate from the y. Okay, so what's going to happen? Distribute the 2. So that makes it 2 squared y to the, so the y has an exponent raised to another exponent.
Y to the 6.
Y to the 6. You're going to multiply power to power. Okay? When you have two of the same base, that's when you're adding exponents. But if you have an exponent raised to another exponent, you multiply. Okay? So then 2 squared is 4, so I have 4y to the 6th power. Okay, do we understand that? All right. So example 8, I've got parentheses, and I have negative 5 x squared y to the 4th, all raised to an outside 3. So negative 5 x squared y to the 4th raised to the 3rd power. Okay, I want you to do this one. Do we have an answer? Don't tell me. But do we have an answer? Okay. I want you to look at the person next to you and y'all talk through your steps. See if you got the same thing. If you are by yourself, go to the person so you can with them. Y'all two can go. You can go to their steps.
I actually don't know if it's just one or two times.
So if you didn't know how to do it or couldn't finish it, have the person next to you see if they can walk you through it and you understand it.
So it's all one now?
I don't know.
Yeah. I don't think that's right.
Oh, I wrote that.
Okay, did you get the same answer as your partner?
I wrote down wrong.
Okay. So how many terms technically are inside parentheses? 3. So all 3 should take that outside exponent. So you should have negative 5 inside parentheses. If you didn't write it inside parentheses, make sure you fix that. Okay, if you have a negative base, it has to stay inside parentheses. So that will take the 3. And then x now has an exponent of what?
6.
And y now has an exponent of? So my final answer should be? Very good. Okay, do we feel okay so far? All right. Questions? Okay. So number 9, you've got in parentheses 3x squared y to the 4th, now raised to the negative 2 power. And now I want you to do this one. And now talk through it with your partner.
It's wrong. I think she needs to be one. Okay, so did y'all get 1/9 x to the 4th y?
Yeah, it don't match.
I thought it was like all day, and I was like, what are we doing today? And
Okay, what was your first step?
The distributive two.
Distribute the negative 2 to all 3 terms. So that tells me I have 3 to the negative 2, x to the negative 4, and y to the negative 8. Now, every single one of those exponents have a negative. So they're all going to go down to a denominator. Is anything going to be in the numerator? Any of these terms? No. So it's going to be 1 over your 3 squared x to the 4th and y to the 8th. Okay, so if everything, so you should never have multiple fractions as your final answer. It all gets condensed down to 1. Okay, so even if this was a 3 to a positive 2 and the rest were negatives, that 3 squared would say everything else would go below it. Okay, so everything is always one term as your final answer. Okay, so my final answer should be 1 over 9x to the 4th y to the 8th. Okay, are y'all good with that? Are y'all following these properties? Okay, because they only get larger. Okay, so do we understand? These are like very simple, basic ones right now. Okay. Now, we're not going to get into the huge ones until about halfway through this page. Okay, so we still have some simple ones going. So, now, if I give you x to the 7th over x to the 4th, this is simple. Okay, but you have to know what the property is. If you don't know your properties, this isn't going to make sense. I'm dividing x to the 7th and x to the 4th. So what do I do with my exponents? Subtract. So if you need to do 7 minus 4 as your middle step, you can. But you can also go straight to your final answer, which is x to the 3rd power. Okay. Now, what if I have x to the 5th over x to the 9th? x to the negative 4. When you are dividing, you always do top minus bottom. Your top exponent in your numerator minus the exponent in your denominator. So that's going to give me x to the negative 4. Okay? But what happens with x to the negative 4? You move it down. So my final answer should be 1 over x to the 4th. So I'm going to write this. Never leave your answer with a negative exponent. I'm just going to say never leave a negative exponent for time. Okay, never leave a negative exponent. Okay, we ready for our third example? All right, I've got a fraction. My numerator is negative 2x. My denominator is just y. And all of that is raised to an outside 4 power. So negative 2x over y raised to the 4th power. What do I do with that? I'm going to distribute the 4 to the negative 2, to the x, and the y. Okay, how do I write negative 2? In parentheses, it's a negative base, so negative 2 in parentheses raised to the 4th is the proper way, or you're going to get the wrong answer. Okay, and then x to the 4th over y to the 4th. Okay, now in your calculator, what is negative 2 to the 4th power? Okay, you should have 16, not a negative 16. If you gave me a negative, that means you didn't type it with parentheses. Okay, you might write it with parentheses, but not type it with parentheses, so you have to be careful. So this should be, your final answer is 16 x to the 4th, y to the 4th. Okay. Example 4, I've got another fraction. I have x to the negative 2 power over y cubed. And all of that is raised to the negative 3 power. What do I do with that? I distribute that outer exponent before I move things. Okay? So I'm going to distribute that negative 3 to the x and the y. So x to the negative 2 raised to the negative 3 gives me x to the what power? It's now a positive 6. Okay? And then y now has an exponent of what? Negative 9. So what do I do then?
Bring the y negative 9 up.
Bring it up, and my final answer should be?
X to the 6.
And nothing should be in a fraction anymore. Okay. Okay, so this next one is a little bit more. Okay. So our numerator is negative 4x squared. Our denominator is x cubed z squared. All raised to an outside 3. I write my z's with a line through it so you don't mix that up with my 2's. I'm just telling y'all that's what they look like when I do a z. Okay. Now, when you have something like this, what do you notice inside parentheses? Okay. And so what do I need to do? What do I need to make sure I do with a negative 4? Write it in parentheses. What else do you notice inside parentheses?
Like terms?
Like term. I have an x squared over an x to the cube. They might not be directly above each other. They're a little diagonally, but I have one in the numerator, one in the denominator. I am always going to simplify inside parentheses first. That makes it less that I have to distribute. If you want to distribute, then simplify, that's fine too. As long as you do the proper steps, either way, you should get the same answer, okay? I personally will always simplify first, okay? So what I'm doing, if I'm looking at this, I've got an x squared over x cubed. So what does that tell me?
To subtract.
I subtract them, and that gives me x to the negative 1. So what I'm going to do is I'm going to rewrite this. If I have a negative 1 here, where should it really go? It goes in the bottom. So I have my negative 4, but I'm going to move that x to the bottom with the z squared. All raised to the outer 3. So if you simplify and you get a negative, that goes in the denominator. I'm going to abbreviate the denominator. It goes in the denominator. Okay? Now what do I do? Distribute the 3. So negative 4 takes the 3, x takes the 3, and z squared takes the 3. Okay, so I've got negative 4 in parentheses to the 3rd power over x to the 3rd power and z to the what power? 6. What is negative 4 to the 3rd power? Over x cubed z to the 6. Now, could you have left it x to the negative 1, distributed the 3, get a negative 3, then move it? Yes. Okay, that's okay also. As long as you work your way down to get rid of the negative x. Okay? All right, number 6. We've got in parentheses, negative 4, x to the negative 5, y cubed, close parentheses. Then we have another set of parentheses right next to it, 7, x to the negative 2 power, y to the negative 7th power. And what operation is that? Multiplication. So don't overthink this one. You're going to multiply like terms, okay? What's negative 4 times 7? Negative 28. When I multiply x to the negative 5th times x to the negative 2 power, when I multiply like bases, what do I do with the exponents? I add them. So I have x to the negative 5 plus negative 2. What's negative 5 plus negative 2? So I have x to the negative 7th power. Okay? Then when I do y cubed times y to the negative 7, I've got y 3 plus negative 7, which gives me y to the what? Negative 4. Okay, did y'all follow that? Okay. So now what do I need to do? I bring my negative exponents down. If you want to draw a line so you visually see, because not everything goes down, you can. The negative 28 does not go down. It is a negative number, but not a negative exponent. Okay? So only x to the negative 7 and y to the negative 4 is going to come down. Okay, so my final answer should be negative 28 over x to the 7th and y to the 4th. Do we understand that? Okay. So this next one, number 7. You've got a fraction. Your numerator is negative 3 x cubed y squared z to the third. So my numerator is negative 3x cubed y squared z to the third. And my denominator is 27 x cubed y to the sixth and z. Okay. Now, how many like terms do you have? Technically 4. Okay. If you want to do color coordinated, you can. You can use a highlighter, you can do colored pens, or you can just visualize it. Okay. What I do is I separate all those individual terms. Okay. So I'm looking at negative 3 over 27. Okay. So if I'm looking at that, let's say I do colored pens. If I have negative 3 over 27, can that reduce? If you don't know, remember you can use a calculator.
-1.
So negative 3 over 27 is negative 1 over 9. Okay? So that means I know I'm going to have a fraction still, because that stays a fraction. Okay? Now, if I look at the next term, I have x cubed over x cubed. What happens there? Cancels, because 3 minus 3 is 0. Anything to the 0 power is 1. So that goes away. I don't have an x at all. Okay? Now, if I look at y squared over y to the 6th. So I've got 2 minus 6, which is y to the negative 4. That would go where? In the bottom. Okay? Now, if I have z cubed over z, I'm subtracting 3 minus what? 1, which leaves me with the square. You see how I broke down each individual one? Okay, if you do it that way, it's so much easier. Okay, so I've got a negative. I'm not going to write a 1. You can if you want. I'm not going to count off, but I'm not going to do a 1. Okay. The y to the negative 4 goes next to that 9, but it's going to be a positive 4. That z squared, does it go in the top or the bottom? The top. So I have a negative z squared over 9y to the 4th. And remember, everything should be one fraction, not multiples. I should not have a negative 1/9 z squared over y4. Okay, it should all be together. Do we understand how I put that together? You're gonna have things like this. So do not skip those on the worksheet. Don't copy it either. Know how to do it. Okay. Number 8. I've got another fraction. My numerator is 16 x to the 4th, y to the negative 5th. 16 x to the 4th, y to the negative 5th. And my denominator is 2 x to the negative 3rd, y to the negative 2. Okay, me personally, I will treat this like I did this one before I move negatives. Okay, I feel like if you move negatives first, you're kind of wasting extra steps. Okay, so I'm going to look at it and separate 16 over 2. And then I'm going to have x to the 4th over x to the negative 3. And then I'm going to have y to the negative 5th over y to the negative 2 power. That's how I would separate it. Okay? I want you to work this out and see if you can work through to the answer. Be very careful when you're subtracting negatives. Okay, what's 16 divided by 2 simplified to? 8. And then, what are you doing with your x? Very good. 4 minus negative 3. You have to be careful with that. You're not doing 4 minus 3. It's 4 minus negative 3. Okay? 4 minus negative 3 gives you x to what power?
7.
Okay? When you're doing your y, you've got negative 5 minus negative 2. That's going to be where people mess up, is minus the negative. Okay? So negative 5 minus negative 2 leaves me with what? Y to the negative 3. What happens with y to the negative 3?
It goes to the bottom.
Goes to the bottom. And it becomes positive y third. So 8x to the 7th over y cubed. Okay, do we feel okay about that? Do we have questions? Okay. Okay, example 9. I've got in parentheses 2x cubed y cubed, close parentheses. And then another set of parentheses, negative 5 x to the 4th y squared. I want you to talk with your partner and work that together.
So would that be? Oh yeah.
So start with, what operation am I doing? If you don't know how to start, ask yourself that. And then that leads you to what rule? Oh. You just have to know what you're
I
doing.
got 2x. I don't think I know what I'm doing. Are you sure?
It's supposed to be 2 multiplied by everything.
Okay, if you're still confused, look at number 6.
So it's negative 10x.
Reference number 6 if you need help.
right? It's 7. And then okay, that was not that hard.
Okay, what's your answer?
-10, X to the 7, Y to the 5th.
Very good. Okay, you only multiply like terms.
And the answer, you don't have to put,
No. Okay, are we good to do number 10? All right, number 10 is a large one. You have to get it down. Okay, so if you've zoned out, I need you zoning back in. Okay, so you're gonna have a fraction within parentheses. Okay, your numerator is 5x cubed y to the negative 2 power in z. Okay, then your denominator is 2x to the negative 1 power, y to the 5th, and z to the 6th. All raised to the negative 2 power. Okay, you can do this 2 ways. Everyone always picks one or the other, it doesn't matter. You can simplify within your parentheses first, or you can take that negative 2 and distribute it to every single thing, then simplify. I personally like to simplify first, and then I distribute. Okay? So if I do that, I'm looking at my 5/2. Does that simplify? No. Then I'm going to look at x cubed over x to the negative 1. So I've got x 3 minus negative 1. What does that give me? X to the 4th. Does that go on the top or the bottom? Top, because it's positive. Then I've got y to the negative 2 over y to the 5th. So negative 2 minus 5 gives me y to the what? Negative 7. It's negative. Where does it go? The bottom. So it's y to the 7th on the bottom. You understand that? Okay. So then I've got z over z to the 6th. So z 1 minus 6. Negative 5. So where does that go? The bottom. And then I have an outer exponent of negative 2. So even though it looks awful, simplifying inside is really not that bad. Okay? So now what are we going to do? Distribute the negative 2 to everything. Okay? So it becomes 5 to the negative 2. X to the what? Negative 8. Over 2 to the negative 2. Y to the negative 14. And z to the negative 10. What do you notice? Everything has a negative exponent. So everything flips. Okay? So I've got 2 squared, y to the 14th, z to the 10th, over 5 squared, x to the 8th. Can I leave it like that? No. What's my final answer?
4, 5, 2, see that it's over 25 actually.
Very good. Now, there's only one of those examples in the notes, but you will get your practice in the worksheet, and you will see it again, so you have to know how to do that. Okay? Do we have questions on those steps? No? Are we okay so far? All right, now, what's going to happen is you're going to have equations. Okay? So I'm going to give you the first example, and then I'm going to go into it. Okay? So my first example says x to the 21st power equals, in parentheses, x to the 4r, and then in another parentheses, x to the 5th. Okay, so you're going to have things that look like this. Okay, and I'm just going to tell you solve for r. R is in your exponent. Okay, so for your exponents to be able to be solved, your bases have to be the same. Okay, you are reducing the right side to get down to just one x. So you're using your properties of exponents to get like bases. Okay, once your bases are equal, then your exponents are equal. Okay, so if I'm looking here, what operation am I doing between x to the 4r and x to the 5th? Multiplication. So when I'm multiplying, what am I doing with my exponents? I'm adding. So x to the 21st is equal to x to the, I add 4r plus 5. Why does that not become a 9r? They're not like terms. One is a variable, one is a constant. Okay, now do you see that you have one base on each side and they're both the same? Okay, it's easy when it's variables. They're not all going to be variables. Because these are equal, my one-to-one property tells me if my bases are equal, my exponents are equal. So now that I've got it down to this, I can just set 21 equal to 4r plus 5. Now that's a two-step equation. What do? I subtract 5. So 21 minus 5 is? So 16 equals 4r. Then what do? Divide by 4 and r equals 4. You can plug r back in. 4r, 4 times 4 is 16. If I add 16 and 5, does that give me 21? Yes. Okay? Now, when you have numbers, it's a little bit different. When you have numbers as your basis. So if I have 2 to the 3r minus 3, not 2, 3r minus 3 equal to 64. Okay. Are my bases the same? No. So in my steps, it says do not make a number bigger or smaller. What that means is you're not going to divide by 2. I get that all day long. You are not doing that. You can only manipulate the number to a power. So what that means is I want to change 64. I want to change this larger number to a base of, what do you think? 2. This has a base of 2. So I need the 64 to have a base of 2 to some type of exponent. Okay, the question mark is the spot for the exponent. Okay, so if I have 2 to the 3r minus 3, I need 64 to become a base of 2. 2 to what power is equal to 64? If you don't know that off the top of your head, you take your calculator. And I'm like, okay, 2 to the, I don't know what power. So 2 to the 4th power, I don't know how much screen is. 2 to the 4th power, 16, not 64. So I need to be larger. Okay, so 2 to the 5th, not there. 2 to the 6th gives me 64. So if you don't know right off the top of your head, just start plugging in numbers to get there. Okay, so 2 to the 6th is equal to 64. Now do I have like bases? Yes. Okay, so I'm going to make that larger number have the same base as what I already have written. Okay, now my bases are equal. I can set 3r minus 3 equal to 6 and solve. What do I do? Add my 3, so 3r equals 9. Divide by 3 and r equals 3. Okay. We got 3 more examples. Okay. This next one is 4 raised to the r plus 2 power equal to 16 raised to the 3r plus 2 power. So 4 raised to the r plus 2 equals 16 raised to the 3r plus 2. Are 4 and 16 like bases? Could I make my larger base? Could I manipulate that to be a smaller base? Yes. 16 is the same as what? 4 squared. Okay. So 16 is equal to 4 squared. So I can have 4 raised to the r plus 2 equal. Now, since I have an exponent already, I'm going to write this 4 squared in parentheses because that is what's being raised to the 3r plus 2 power. Okay, do we understand how I manipulated 16 to become a 4? Okay. Now, what do you notice when you have an exponent raised to an outer exponent? What do I have to do there? I have to multiply. When I multiply, I have 2 terms. So I'm multiplying 2 times 3r and 2 times 2. Okay, so I've got 4 raised to the r plus 2 power equal to 4 raised to the what power? Plus 4. 6r plus 4. Very good. Now do I have like bases? So what do I do? Very good. Okay, I've got variables on both sides, so I'm going to move one of my variables over and my constant to the opposite side. Okay, so if I move my 6r, I'm going to subtract 6r. And if you want to subtract your 2 in the same step to get rid of it, you can. So that leaves me with a negative 5r equals 2. What do I do? Divide by negative 5, and r is equal to? Okay. Do you have questions? Example 4, I've got x squared times x to the r in parentheses raised to the 3rd power equals x to the 18th power. What do you need to do? Okay, you can do that, or what else could you do? Okay, so I have 2 x's being multiplied. If they're being multiplied, what do I do with my exponents? Add. So instead of 2r, it could be 2 plus r. raised to the third power. If you distributed your 3 first, that would have been okay also. You would just have to add them afterwards. Okay, here I added them first, and then I'm going to have to do what with this 3. So multiply it, which I'm about 2 terms, so I'm going to distribute. So that becomes x to the what power? Plus 3r equals x to the 18th. Okay, now what do I do? Equals 18. Subtract your 6, and 3r equals 12. Divide by 3, and r equals 4. Okay. Number 5, I have x to the 4r over x to the negative 2r equals x to the 30th. What do I do with that? Okay, I can do that, or I could just subtract. It doesn't matter. When you have a negative exponent, you can move it and then do the operation, or do the operation and see if you need to move it. Okay. I personally recognize I'm dividing like bases, so I'm gonna do what with my exponents? Subtract them. So 4r minus a negative 2r is what I'm doing. So I'm gonna write that so you see it. 4r minus a negative 2r is gonna give me x to the what? 6r. And that's gonna equal x to the 30. If you moved the negative 2r up, you would be multiplying those x's, so then you would add and still get 6r. Okay? Now, I can set 6r equal to 30, and r equals 5. Okay? These notes are long because your properties of exponents are very important. Okay, we are going to do properties of rational exponents, which means we're going to take all of these properties and do it with fractions as exponents. Okay, so you have to be able to do the fundamental lesson like this before we move on. Okay, so you're going to have a quiz over this lesson next class. Okay,